Right guys, as promised, video on these 11 kV fuses. These have come out of substations. We've got rather a quantity of them. They've all been upgraded because we're all using a little bit too much electricity these days, and the primary fuses on the 11 kV transformers need to be a little bit bigger than this. I think this one is, it's only 36 amps, but 36 amps at 7 kV or 11 kV is quite a bit of grunt. So we're going to have a look at these, we're going to blow them up and do whatever's necessary, and we'll have a look in detail. Because we're all using a bit too much power these days. It's probably my fault. Well, there's one of our small fuses, what go in a 13 amp plug. That's just a 3 amp. But we're going to look at these today. Much better. So let's open it up carefully, shall we? Right, there's the inside. As you can see, it's made up of a few strands wrapped round one end to the other. And in the middle, we've got our striker mechanism, which hopefully we'll be able to see. Let's have a close look at this, shall we? Here's that striker part in a bit more detail. In the middle there's another really fine wire which also carries the trigger current, which isn't very much. It's when that outside bit's popped, which carries the main current, then it has to go through that trigger mechanism, and in the end there's a little pyrotechnic charge, and then the pin pops out. Right, let's pop the main current carrying part of this. That's that. Didn't take much to break that, did it?
Right.
Yeah. So that main part, yeah, it's all gone. That's what that stands for, it just quenches that arc. Now then, let's pop this little device. There's a little bit more voltage to do that. It's got a high resistance. Right, let's try this, because we've got a few more volts now. Hopefully it'll trigger that device. There you go.
There it goes.
Yeah. And now we can see that little charge was in there. There was a tiny fine wire coming off of there, coiled up, and it was a higher resistance than the other main conductor. And that's it. It's quite sharp. So yeah, that ID's when the fuse is actually gone, and trips out any remaining phases that have not tripped. And that's all that does. 80 amps that way. It takes about 3 times rated current to actually pop that. Right, here we go, one more, boys. That's that. I popped it. There you are. I think there might be a few of these laying around somewhere, boys. Let's check it out. I'm trying to decide what's more sexy. A box of bushings, a whole load of high voltage fuses, or the missus. Ah, no contest.
Don't tell me the fuses have it, right?
No. See, the National Grid don't have to keep coming round now, putting new ones in the transformer. I'll do it. Ah, do you remember this one? Shall we have a look inside it? That is tasty. That could run 6,000 amps if there was more strands in there. I think each one of them's about 100 amps. Loads of them. Of course it was filled with sand. So there you are. You've seen inside that. Of course that's where it belongs now. as usual guys, big thanks for watching, and we will definitely see you on the next video coming up shortly.